Now is the right time for Corsage, continuous orbital remote sensing of archipelagic geochemical events. Brought to you by this team. The image shows the sediment plume from the Bermuda platform generated by the passage of Hurricane Gert on September 22, 1999, the first identification of a remotely sent sediment plume from a carbonate platform observed by SeaWiFS and described in this publication. Why was Corsage envisioned? In 1997, anticipating the launch of SeaWiFS, the idea of continuous orbital remote sensing of archipelagic geochemical events was proposed. 5 years later, Corsage was presented in a more fully formed fashion, including the types of geochemical events that were of interest to carbonate sedimentologists. It was to be an interagency project with critical input from researchers in the field, and most significantly, it was an effort rooted in fundamental scientific questions rather than a survey-style effort. Some of these questions. Could such events be observed and identified reliably by satellite remote sensing? How often do sediment transport events from archipelagos occur, and how much sediment is exported? How far and how deep are these sediments transported? Would such a project be capable of providing a first estimate of the global mass of exported sediments annually? Can such estimates be incorporated into global carbon cycle models? And how does the mass of export events compare to pelagic aragonite and calcite fluxes? Why are carbonate sediments important? Carbonate platforms and coral reefs are the most productive calcium carbonate regimes in the oceans. Carbonate sediments are important records of paleoclimate and ocean paleochemistry, lending insight into modern climate and ocean change. Carbonate sediment minerals aragonite and magnesian calcite are more soluble in seawater than calcite. Carbonate sedimentation processes are dynamic and complex and will be altered by rising sea levels. And carbonate sediments can dissolve at shallow depths in the ocean water column, helping to close ocean carbonate models based on seawater chemistry measurements. Primary questions to address. How and where is fine aragonite sediment produced in shallow water settings, and how and where is this material transported to deep water settings? Why wasn't Corsage pursued in the early 2000s? Even when SeaWiFS observations were augmented by MODIS on Terra and Aqua, coverage was still insufficient. Maximum spatial resolution was about 1 kilometer. Large export features could be observed, but not small export events and sedimentary processes. Algorithms for mass estimation were preliminary and based on radiometric models and were not sea-truthed. Data access was limited and imagery was not as readily available as at present, and scientists had moved on to other things. Why is now the time for Corsage? We now possess capabilities envisioned 2 decades ago for Corsage, including high-resolution imagery not routinely available back then. There are many more sensors in orbit, and imagery is far easier to access and categorize. There are also autonomous vehicles and floats that can make in situ measurements, including ocean water optics and chemistry, in active sediment plumes from surface to depth. 20-plus years of retrospective satellite-derived model data can be analyzed, with a diagnostic capability for wind speed and direction, surface wind stress, surface temperature, sea surface temperature, and improved optics. Other mechanisms of off-bank sediment transport, such as polar air outbreak-induced density flows, can also be observed, and also whitings. Thus, much better quantification is possible. There are now more satellites and advanced satellite instruments with higher resolution and more data, including the Ocean and Land Color Imager, Landsat 8 and 9 to be launched in September, the Visible and Infrared Imager Radiometer Suite, and in November 2023, the Plankton Aerosol Cloud Ocean Ecosystem PACE mission. There are now many data portals and data services which provide comprehensive coverage and facile analyses. NASA Worldview, which you will see many images from later, NASA Giovanni, which provides numerous different analytical capabilities, and the ESA Copernicus Open Access Hub with data access to many different kinds of satellites. Advanced autonomous underwater vehicle technology is now available, and it can be deployed to characterize events as they are occurring. Shown here is Stella from the University of South Florida and an Embari glider equipped with an oxygen and pH sensor. Potential results from Corsage include vastly improved quantified observations of event frequency, aerial extent, and sediment mass, a predictive capability for event occurrence, data that can be integrated into global carbon cycle models and ocean carbonate system models, an assessment of how this process can fit in with many global change processes, and a potential revision of many standard ideas about how carbonate sediments are generated, processed, stored, and exported to the deep sea using remote sensing data that has been generally overlooked by the marine geology community. Now let's look at some observations. Hurricane Fabian created a beautiful sediment plume off of Bermuda. Hurricane Francis plowed through the Bahamas, leaving many sediment plumes in its wake. And devastating Hurricane Dorian nonetheless created magnificent sediment plumes offshore of the Bahamas. This is an important global phenomenon. On October 5, 2018, a large sediment plume was viewed off of French frigate shoals. And this is significant to the global carbon cycle because carbonate dissolution horizons in the North Pacific Ocean are much shallower than in the Atlantic Ocean. Severe Cyclone Yasa passed over Fiji. The wind field is shown here visualized with NASA Giovanni using hourly data. The effects can be seen both for river runoff and for reef sediment export. In March of 2006, on the Bellona Bank in the Coral Sea northeast of Australia, Cyclone Wadi stalled, and after it passed, resuspended sediments made Bellona Bank glow over a distance of 120 miles. Also observable are whitings, which are spontaneous calcium carbonate precipitation events, which are observed in many tropical carbonate environments. They are unpredictable, difficult to characterize, and not fully understood. Corsage provides the opportunity to dramatically expand whiting observations. Because whitings appear to be dependent on the oceanic carbonate system state, ocean acidification may change both their frequency and extent to the point of ending their occurrence. Corsage can provide unprecedented insight into sedimentary transport and deposition processes. Not just hurricanes, but polar air outbreaks can provide energy that mobilizes and transports sediments. And there are different modes of transport: leaking a small amount over the side of the bank or shedding an extremely large amount in a very small amount of time. Corsage can make great contributions to the field of ocean optics. In 2001, Hurricane Michelle passed over Cuba, and the winds were such that they caused a sediment export event from the Gulf of Batabano. Using SeaWift's data at that time, the sediment plume was observed for 5 days, extending about 200 kilometers. The mass of sediment in the plume was estimated by a preliminary algorithm. Because calcium carbonate sediment is both brightly reflective and not buoyant, observing this feature for 5 days was quite interesting because it indicated a very slow settling rate due to fine-grained sediments and also in very clear water. Using MODIS aqua data, it was determined that the sediment plume was actually visible for 10 days, which has important implications for both ocean optics and sediment geochemistry. Traces of the plume were still detectable 10 days after the passage of Michelle. And now, a near real-time examination of the effects of Hurricane Ida on western Cuba. Here is a comparison of MODIS aqua imagery for August 25th and August 29th. Small sediment export features are visible in this comparison. Every event is different. While Ida passed directly over the Gulf of Batabano, it had minimal hurricane wind speed, and wind direction may have limited sediment transport out of the bay. Resuspension is obvious from brightness. Tidal currents could still export resuspended sediments out of the bay, which may be occurring for the features highlighted on August 29th. In contrast, Michelle passed to the east of the Gulf as a much stronger storm. The final sector of the storm over the Gulf provided strong northwesterly winds pushing water and sediments out of the Gulf, resulting in the observed long-lived plume. Corsage can make a detailed level of analysis and quantification of sediment export mass possible for individual events such as this. The Corsage team provides decades of experience in satellite data access and visualization in ocean carbonate chemistry, carbonate platform evolution and sediment stratigraphy, ocean optics, algorithm development, and satellite data applications, sedimentary geology and stratigraphy in carbonate or mixed siliciclastic and carbonate environments, and expertise in the global carbon cycle, the role of the ocean absorbing CO2, and advanced ocean chemistry sensors. Now is the time for Corsage.